When asked to analyze the discriminant, the first thing we need to remember is what in the world does that even mean when you're asked to do that? Like, what math does it actually ask you to do? And when you find the discriminant, we are just going to analyze the square root part of the quadratic formula to decide if a quadratic equation is factorable or prime, meaning we can't factor it at all. And so we're just going to do b squared minus 4ac, get it down to one number, and then analyze it. So we're going to do that for 3 different quadratics and decide what does that discriminant tell us about that quadratic, if it's factorable or prime. So for each one, we're going to set up the square root of b squared minus 4ac. Now, whenever you find x squared, you know you have a, regular x with your linear term is b, your constant is c. The number with your quadratic term is a, the linear term is b, constant is c. If there's no number, we assume there's a 1, so that quadratic term is an a, then we have our b, then we have our c. So we're going to do the square root of b squared minus 4ac, so we're going to see 10 squared minus 4 times a times c. In this case, a and c are the same. And we'll set up this one as well. B squared minus 4 times a times c. B squared minus 4 times a times c. Now your next step when you analyze the discriminant is to do all the PEMDAS to get that down to one. So after you do all the PEMDAS and you get one number underneath the square root of the b squared minus 4ac, that one number is the discriminant. Now we have to decide, does that tell us the quadratic up above is factorable or prime? The square root of 36. We know that the square root of 36 is a perfect square because 6 times 6 is 36. If you can take the square root and get a perfect whole number, we know that that quadratic above is factorable. And so you must factor it to find the solutions if that pops up in your math. Any single time you end with a negative, it doesn't matter what number it is. If it's a negative, you know we're gonna have imaginary solutions. So that quadratic up above is prime. And so to get the solutions, it's quadratic formula time, everyone's favorite. Last example, square root of a positive 5. If you take the square root of that number and you get a crazy decimal, which would happen with the square root of 5, that's also prime. So it's quadratic formula time.